Today we're going to be looking at single inequalities with two variables. First we have this equation. Y is greater than or equal to 3x plus 1. The question is, let's graph it and find where all the solutions are. So to do that, we're going to pretend like we're going to graph what I call the boundary line, just the line y equals 3x plus 1. The line y equals 3x plus 1 has a y-intercept at 1, and then has a slope of 3 over 1. So I'm going to go up 3 over 1, up 3 over 1, and then I want to kind of fill up the whole graph, so I'm going to go down 3, backwards 1, backwards 1, backwards 1. Now, because it's a greater than or equal to sign, that means I'm actually going to connect the entire line. So I'm going to go from here all the way down. All of those are solutions, just like if it was y equals. But this says y is greater than. That means I want all of the y's that are above the line. So if I look for those, I'm looking for values of y that are above the line. So I'm looking for just pick any point on this line and then go straight up. That's the area I'm trying to, these are where the solutions are. So I'm just going to shade this whole section. And just to kind of, show you that we shaded right, because we always want to make sure that what we did is right, is I'm going to pick a random point. I'm going to pick one maybe right here. This is the point negative 7, 4. And I'm going to plug those values in. So 4 is greater than or equal to 3 times negative 7 plus 1. And that is 4 is greater than or equal to, if you type that in, it's negative 21, it's negative 20. Surely 4 is bigger than negative 20. So what we've done is we said these are solutions. What about the points on the line, like this guy right here? That's the point 2, 7. Let's see if he's a solution. I'm going to plug 7 in for y. Greater than or equal to 3 times 2 plus 1. Here I get 7 is greater than or equal to 7. Is that true? Yeah, because 7 is equal to 7. So what we see is that the points on this side of the line that are above the line and points that are on the line are both solutions. Let's look at a couple more. I want to graph this one. Again, to graph it, one of the easiest things to do is get into slope-intercept form, or y equals mx plus b form. So I'm going to subtract 20x from both sides. If you want to, you can draw an invisible line down. That brings down to negative 5y is greater than or equal to, I cannot combine these whatsoever, because one's an x and one's not. So move like that, but now I got to divide by negative 5. And when I divide by negative 5, I have to divide everything by negative 5. And because I divided by negative, I have to flip the inequality to a less than or equal to. And that would be positive 4x, and that would be negative 6. So I'm going to come over here, my y-intercept is negative 6. And my slope is 4 over 1. So I'm going to go up 4 over 1, up 4 over 1. Notice that when I go over, I'm always going to the right. It doesn't matter if it's a positive slope or a negative slope. Always go to the right first, and then if you need to go down 4, then you can go backwards 1. And I'm going to connect that line. Because it's a greater than or less than or equal to, still an equal to, I'm going to draw the whole line. Then, because it's a less than or equal to, that means I want all the y's that are below the line. So pick any dot on the line, like right here, and go straight down. Any dot and go straight down. Any dot and go straight down. So now you know where the area is. It's over here. It's this side of the line. That is what we call a boundary line. It's like a fence. We don't want to cross the fence. Okay, so I'm actually going to erase where I did cross the fence right there. Here we go. So again, what I did is I just showed you where all the solutions are. The solutions are going to be on the line or in the shaded area. So if I wanted to test a point such as this one right here, 8, 0, I can plug it into the original or this one, doesn't really matter. If I plug in 8, 0, I get 0 is less than or equal to 4 times 8 minus 6. Well, that 0 is less than or equal to 32 minus 6, 26. And that's true. So again, these are the solutions. If you picked a point over here, it wouldn't be a solution. So the reason I shaded down this time, I went straight down when I shaded, was because I had a less than. Straight down. Straight down. Because of the less than. Next one, it's messy looking. It's not slope-intercept form. So let's go ahead and distribute first. So y plus 5 less than 3x plus 12 minus 2. Let's combine our like terms. That's 3x minus 10. 12 minus 2 is 10. Or plus 10, sorry. 12 minus 2 is positive 10. Now let's subtract 5 from both sides. Y is less than 3x plus 5. Notice how I treated that just like I would a normal equation. And now I'm going to graph this. It has a y-intercept of 5, that's this number right here. And it has a slope of 3 over 1. And then I kind of run out of room, so I'm going to go down 3. And then down 3 over 1. Down 3. And do this all the way, because you don't want to, you want to fill the entire graph, you want to know the entire boundary. But this time it's a little bit different. I don't have a less than or equal to, I just have a less than sign. So like before, when we did open circles or we did closed circles, well now we're doing solid lines or dotted lines. So really I just want a dotted line that goes from, let's see, or that goes here. So I'm going to do this guy. Okay, I just want it to be dotted because it was a less than. The question is, which side are the solutions? Is it this side over here or this side over here? We'll do that. We go back and we look, and it says y is less than. So that means I want to pick any point and go straight down. Pick any point and go straight down. That's how I'm going to shade. So this is the area that I need to shade. Do a good job of shading so it fills up the entire thing. If you want to use colored pencils, that would be great. If you just want to use different colored pens, that's cool too. If you want to use crayons, that's okay. But there are the solutions. So the difference here, though, is that we have a dotted line. So if I look at the solutions, we know this point's a solution. We know this point's not a solution because this one's shaded, this one's not. But what about this point right here, the point 1, 8? That's on a dotted line. Let's plug it in. 8 is less than 3 times 1 plus 5. That is 8 is less than 3 plus 5 is 8. Is 8 less than 8? No, it's not. So there you can see that points on the dotted line are not solutions. The red area is still the solution, the shaded area is still a solution, but because we're talking about a dotted line, it's not a solution. Alright. Last one, I think before that you try. X is greater than 4. How is this different from all the rest? Okay, it starts with an X, but it also doesn't have a Y. And remember, when we're missing a variable, that means it's either a horizontal or vertical line. So look here, X, pretend that goes X equals 4. If it goes X equals 4, I'd put a dot on X equals 4. And then because it doesn't have a Y, it's not going to cross the Y-axis. Or X is always going to have to be 4. Is it a greater than, if it was this, sorry, if we had this, then it'd be a solid line, but because it's just greater than, we've got to do a dotted line. It basically goes straight up and down. Now the question is, what side are we going to shade? Here, it doesn't say y's are bigger or less than, it says x is bigger than 4. It means I want all of my x's that are bigger than 4. Well, where would that be? Well, here x is 4, and here are the x's that are bigger. So I want to shade everywhere to the right. This is the only time you think right and left, because we're starting with an x. If we were starting with a y, we always think up and down. Alright, so there would be our solutions. Just quickly have a little discussion with ourselves. Is this point a solution? Yeah, of course it's on the red. The shaded area. Is this point a solution? Nope. It's in the white area. Is this point a solution? No, it's on the dotted line. What about this point over here? Yes, it is, because this line would go down forever, and then the red would go down forever. Okay. Oh, sorry, one more. Here, we're going to take the graph and write the inequality. Okay. Remember, to write an inequality, we need y mx plus b. Well, m is our slope, and y is our, and b is our y-intercept. Well, what's our y-intercept? We come over here to find the y-intercept. Oh, it's right there at 8. Now I gotta find our slope. Let me find another good point. Here's another good point. Here's another good point. See what our slope is there. Down 2 over 1. Down 2 over 1. Down 2 over 1. So our slope must be a negative 2x plus 8. Now we just gotta figure out, is it a less than? Is it a greater than? Is it a is it an equal to, or is it not equal to? Well, the way I'm going to do that, I'm going to pick any point on the line. Doesn't matter where, right there. Did I shade up, or did I shade straight down? Not in an angle, just straight up and straight down. Obviously, the solutions are below the line. So that means I'm going to do a less than. Is the line solid or dotted? It's a dotted line, so I'm just going to leave it like that. And that's going to be my answer. Alright, that you try. I have this one. I want you to go ahead and pause the video, do it yourself, and then unpause it and see how you did. Alright, so the first thing we need to do is solve for y. So I subtracted 3x on both sides. And I divided by negative 2. And then I had to switch the sign to a greater than, because I divided by negative. I grabbed my line, I did dotted, because it wasn't an equal to. And then because it was greater than, I had to shade straight up. So I picked a dot and I shaded straight up. Picked a dot and went straight up. And there's my solutions. Alright, last problem. Go ahead and pause the video, do this one. and then check your answer. This one, it just has a y, there's no x. So I put my y at 6. I drew a horizontal line. I did a solid because it was equal to. And then because it said less, then I went below the line. Alright, and here's your summary. Think about these, write them out. Remember, we do this to kind of help you with long-term memory, understanding, so when you take the test, you're better prepared. And we'd like to discuss these tomorrow. Here they are.